So, so let me see. As far as I'm trying to think about my announcement. So this is the end of week 2, right? Hang on. Done. Okay, let's everybody share the screen. Start the broadcast. And we'll start here. Okay. So this is the end of week 2, right? So for week 2, we're responsible for sections 1.2 lines. This past Sunday night at 11:59 p.m., 1.1 was due. But again, with all of our assignments, we get unlimited attempts. And you can work on any assignment past the due date with only a 10% late penalty. And the system is set or is designed to take your highest score. I do want to encourage you to watch the lecture associated with each section. So for instance, with this one being section 1.2, you want to, go to my YouTube and watch the corresponding lecture presentation, the full lecture, so you can get all the details here. And so what we'll do today, I'll just go through as many homework questions from section 1.2 as I can. And if you want to go through 1.1 or something else or jump straight to a specific question, all you have to do is get my attention. This is remote asynchronous, so you're not obligated to stay. If you've made it into the Zoom, which all of you have that's in here right now, you've gotten your attendance credit for the day, you're not obligated to stay. But what I'm going to do is hop over to Pearson and work some questions from there. This is the 4 p.m., this one. Now, I got 3 enrolled. I think I might be missing 2 students. I might have to go track these guys down. Allow. It's this course. 4 p.m. Okay. Allow. And I'm just gonna go ahead and start on section 1.2 lines, and I'll try to fill in with like pertinent details, like as far as things that I would have said in the lecture for each question. So this one asks us to find the slope of a line passing through the pair of points, or state that the slope is undefined, and then indicate whether the line rises, falls, or is horizontal. Okay, so let me start by getting a copy of this. Do one more. I think that's the best. And I'm going to cut this down to size. That one, this one. Like that. Okay. So then I'm going to take this copy and drop it right here. Let me add a page, actually a couple of pages. Maybe a little bit more than a couple. Okay. All right. So fine. So now, one thing that I like to say, whenever we're working with lines, so hopefully you have a notebook where you're neat and organized. In your notebook, the things that you want to have that as organized as possible, a copy of the notes, right? So I do intend to load a student version of the notes, and then there's an instructor version. The instructor version is just going to have more details and like explain how to do all the examples. It is recommended that once you get a copy of the student notes to try to attempt those examples on your own first. Go as far as you can, and then once you've gone as far as you can in those examples, then you want to come back to the instructor notes and fill in missing details. So you want to have a copy of the notes in your notebook. You want to have your homework in your notebook where you have a copy of the original question, any supporting detail, and then the final answer in a box. And then the last part that's recommended to be in your notebook is a formula sheet, all right? It is recommended that you make this yourself. That's where the learning comes from, is creating this notebook. Having a copy of somebody's notebook doesn't really serve you. That's just like having the book. And so then you, like, if you're on an exam and you're trying to use these documents, you're going to be rummaging back and forth, or you're just going to be, wasting all of your time. Versus if you've created it, by the time you get to the exam, you'll have a more intimate level of understanding of the content. And so, like with the exams, as a warning or as a courtesy. So this is the end of week 2, right? Exam 1 will become available the Sunday before week 4, right? So exam 1 will be available during week 4, and I have a prerequisite set. In order to access exam 1, you have to pass the corresponding quizzes. So that's quizzes for weeks 1, 2, and 3. Right now we're preparing for quiz 2. Every week the assignments are due every Sunday night at 11:59 p.m. So this is week 2, section 1.2 is going to be due this upcoming Sunday at 11:59 p.m. And again, we get unlimited attempts at all assignments with a 10% late penalty, and the system is set to take your highest score. Okay, so that's a little rundown of that. So then, now when it comes to lines, there are 3 formulas that you just want to know or have readily available whenever you work with lines. Okay, so the first formula that you want to have available is the slope formula. The slope between 2 points is going to be the change in y, or y2 minus y1 over x2 minus x1. And again, this is the slope between 2 points. So then another formula that we use often when we're working with lines is called the point slope. Point slope formula. Point slope formula, right? And so that equation is going to be y minus y1 equals m times x minus x1. And then the last one is going to be the slope intercept formula. And that's the classic y equals mx plus b, right? So whenever we're working with lines, we typically will flow between one of these 3 formulas, all right? So this question comes from section 1.2. It's question number 1 from the back of the text. And it asks us to find the slope of the line through the points. So basically find the slope, right? So then the slope here, and then also whenever I have ordered pairs, I like to label them. So x1, y1, x2, y2. So then if we're going to find the slope, so our y2 is 3 minus our y1 is 1 over our x2 is 6 minus our x1 is -5. Okay. So then on top we get 2. On bottom, double negative is positive, so that's 11. So then the slope is a positive 2 over 11. Again, if anything is not clear, feel free to unmute yourself and just either unmute yourself or type in the chat. I'll check attendance again and write it about 5 minutes for any stragglers. I'm going to have to track these guys down. I don't think I've seen them. One person may have emailed me and I thought I responded, but maybe I did, maybe I didn't. Okay, so that's fine. I forgot just that fast. 2 over 11. Okay, so let me zoom out. That's fine for now. And let me turn the keyboard off. Let me see if I close this. Okay, we got 2 over 11. Indicate whether the line through the point rises. So because our slope is positive, our line is going to rise as we trace the graph from the left to the right. It's going to go up because the slope is positive. Okay. Let's do this one. This is another one that's similar to what we just did, but a lot of times they have pertinent differences. Let me zoom back out one. Okay, I think that's good. I guess I gotta zoom out again. Come on. Okay, that's decent. And we want to take that and drop it here. And actually, let's just start. Let's put this on the next page. Okay. So again, with this example, we're asked to find the slope of the line through the points. So basically, it's find the slope. So the slope formula, again, one of my professors would say every time you use a formula to write it down, that constant repetitive writing will help to ingrain it in your memory. So the slope between 2 points is going to be y2 minus y1 over x2 minus x1. Also, I'm a fan of labeling my points, x1, y1, x2, y2. Okay. So then our y2 is -2 minus our y1 is -2 divided by x2 is 4 minus 1. Okay. A number minus itself. So this numerator, this top part goes to 0. So then we have 0 over 3, which is equal to 0. All right. So our slope is 0. So let me kind of share this as well. So in this example, we had 0 over some number. So this is okay. This is going to be equal to 0. But if we have some number over 0, that's a KO. You want to knock that out. This is going to be undefined. Right? Undefined. Okay. So we got 0 over some number, so that's okay. So that's going to be equal to 0. So when the slope is 0, that means we have a flat horizontal line. So right here, our slope is 0. And when the slope is 0, that means our line is a flat horizontal line. Okay. Let me check attendance. If these other people have showed up. Okay, so I'm gonna have to track them down. All right, so on to the next question. Find the slope of the line if it exists. So for this one, get a copy and take some notes. So from there to there. Okay. I guess this might be enough space right here. So keep in mind, all that you see me writing, I'll make all the stuff that you see me writing, I will make a copy of it available. So there's a couple of ways we can go about this. We're actually to find a slope. We can either just count so slope is rise over run. We can just count the rise over the slopes over the run, or we can calculate the slope, right? So for instance, this first point, the y-intercept looks like it's 1. So that's the point 0, 1. This second point looks like it's over 7 and down 5. So that's the point 7, -5, right? So they gave us 0, 1, provided we didn't make any mistakes, and 7, -5. And it says to find the slope, so it's probably a good idea to use the slope formula. y2 minus y1 over x2 minus x1. And then also label. So I like to label. So I like to go x1, y1, x2, y2. So then when we go to plug it into the formula, it's practically a direct correlation. So y2 is -5 minus y1, which is 1. Notice my use of parentheses to capture that negative. x2 is 7, and x1 is 0. So -5 minus 1 is -6. 7 minus 0 is 7. So then this is our slope. Okay. And suppose we wanted to count, right? Let's just do one where we count it. Let's do this one in pink. So right here, right? So we got 1, 2, 3, 4, 5, 6. We went down by 6, and then 1, 2, 3, 4, 5, 6, 7, and the run of 7. And so then you see it basically the same thing right here. So these are two different ways of doing the same thing. Okay. So we got a slope of, and notice the slope is a -6/7. And notice as we trace the graph from the left to the right, it goes down. It's falling, right? So a negative slope, when you trace it left to right, it goes down. Okay. So we got a slope of -6/7. So I'm just going to type that in here. -6/7. Enter. Let me zoom out some. Next question. There we go. Okay, find an equation in slope-intercept form of the line that passes through the given point and has that slope. Let's take some notes here. Oh, I didn't realize that. Oh, that helps out a lot, actually. I'm gonna zoom in just a little bit more. Oh, that's too much. Okay, let's get a copy of this. So I'm intentionally trying to include the question ID for each of these. So like if you were trying to figure out where did that come from? Hang on. That looks good. Okay. So then we want to take this and drop it here. It's been a little bit temperamental, but not as bad as it was earlier. Okay. All right. So for instance, this question comes from section 1.2, question number 9 from that section. So if you went to the back of the book, this is the same type of question with just different numbers. So we want the equation of a line is slope intercept. So they want us to finish in y equals mx plus b. Oh, they already gave us all of that, right? They gave us the slope and they gave us the b, so we didn't even have to take any, we don't have to take any notes here. Let me just, I'm gonna delete this one. Right? Because of what they gave us. So they want the result and y equals mx plus b. Let me zoom out some. So if we just go ahead and plug in, our m is 5/6. So let's do 5/6. I think I got to hit control. There it is. So mx and then plus our b is 7 in this case, right? They gave us our wire intercept, so we just put it in there. Okay. And again, you have to stop me if anything is not clear, if I need to slow down or go back or anything. You have to get my attention. Else, I just kind of power through. So then to graph this, we started at the y-intercept of 7. So I'm going to use the line tool, which is the second tool on the top row on the right. My y-intercept is 7, so I want to try to click on the 7, and I got it. And then my slope is 5/6. So I'm going to go up 5 and over 6. So my second point, I'm going to be at what? My x value is going to be 6. My y value is going to be 12. So 6, 12. Let me see. So what I'm going to do is just drag until I get to 6, 12. Okay. And now I'm going to hit save and check. Okay. So what I did there, I started with my y-intercept of the 7, and then I used the slope to get to a second point. Okay. Oh, find the equation in slope-intercept form that passes through. Okay, let's give this one a go. Let me zoom in some. Maybe I can make it a little bit bigger. So this is pretty good there. Okay, let me get a copy of this one. So, with this information, just do the best that you can. I've been teaching this kind of stuff for about a decade now. And no matter whether if we're in person or remote, the way students feel is pretty consistent. It is information overload. I want to say that the concepts are not difficult, but it is a lot of information. And keep in mind that we're doing half the work that we used to do in the past. So, but with being aware of how it makes many students feel, this is why I encourage you. This is why I have it set up the way that I do, where unlimited attempts, only a 10% late penalty. I encourage you guys to work together. I encourage you to seek out the tutor. Pearson explains how to do each question. It's a lot, right? And so you just have to make a plan and execute, focus and follow through, right? But I can't just give you the thing. It's like, I just can't do it. I've even tried that, and that doesn't work either. So, but I just have to encourage you and just try to get you past this little obstacle. One of the biggest obstacles that we have faced as humans, even me and most humans, is laziness, being lazy, right? And so with this information not really being too terribly difficult, it is daunting where it's information overload. So it's very easy to succumb to laziness, procrastination. I'm the king of these energies. And it doesn't really it doesn't allow you to kind of move. It kind of limits you when you do that. So that's why, I try to make things available as early as possible to give you as much time as I possibly can for you to make a plan and take action. But the longer you wait, the worse it gets. The sooner you can start, the sooner you can be done. So find an equation in slope-intercept. So they're asking us to finish in the form of y equals mx plus b. We have our slope. We don't have our b, right? So let's start with the point slope form. So point slope formula is y minus y1 equals m times x minus x1, right? We have our slope. Let's go ahead and label our x1, y1. So this is our x1, y1. And let's plug in what the components that we've been given. So we're going to say y minus 1, our slope is a negative 7/2 times x minus 2. Okay. So then let's solve for y. So a couple of things here. We're going to distribute this -7 by 2, and we're going to add 1 to both sides. Okay. So if we account for those changes, we get the following. Y equals, now we got this -7 by 2x. -7 by 2 times a -2 is a +7. And then we got to keep in mind we still have that +1. So then combine like terms, -7 by 2x plus 8. So notice we still have our slope of -7 by 2. We can confirm that this point works. When x is 2, y should be 1. So then -7/2 times 2 is -7, plus 8 is indeed 1, right? So it works out. So this was our slope-intercept form that we got. Okay. Our y-intercept is 8, and our slope is a -7 by 2. So we got a +8 and a -7 by 2. Let me zoom out. +8 and -7 by 2. There it is. So we got a slope of -7 by 2. Let me get to the side of that. X, and I think we said +8. Okay. And then for the graph, I'm going to click on the graph tool. Let me do something so I can see this as a graph. Okay. So we know we're working with a line. The y-intercept is 8, so I want to try to click on the 8. I'll get it in just a moment. And then we go down 7 and right 2. That's going to put us right about here. Now, our y-intercept was 8. I got to fix that one. So that one's been fixed. Now, if we go down 7 and right 2, we should be at 2, 1, I think it is. 2, 1, right? If we go down 7, now our y value is 1. We go right 2, our x value is 2. So this looks good. I'm going to hit save. Come on. Okay, there you go. And I'm going to check my answer. Okay, let me check Zoom really quickly. Okay, looks like you got, okay, I think that's one of our missing people. Steve, let me get him. Okay, I think that's this student. And we're only missing one, not bad. Okay. Let's go on to the next question. So again, if anything is not clear, just feel free to either unmute yourself to get my attention or type in the chat. I do check the chat periodically. Okay, let's try another one. Use the given conditions to find an equation in slope-intercept form. Slope-intercept is y equals mx plus b, passing through these points. So our x-intercept is -10, our y-intercept is 10. That means our slope is 1, and our b is 10. So we can actually just jump essentially straight to y equals 1 times x plus 10, right? And let's confirm that this equation works. When x is -10, notice our y is 0. When x is 0, notice our y is 10. Okay, so they both work. So that's a slope-intercept form. Okay, so I'm going to go on to the next question. Find an equation in slope-intercept form that passes through the given point and has a slope. Slope-intercept is y equals mx plus b. Oh, okay, this one. Let me zoom in just a little bit. So notice here, our slope is 0. That means we have a horizontal line, a flat horizontal line. That means we're going to have a flat horizontal line that passes through y equals 6. So when the slope is 0, in this case, you can just put y equals 6. What's the time? We got a solid 15 minutes. Let's keep going. So because our slope is 0, it's just going to be a horizontal line through y equals 6. Okay, and then another point on that y equals 6. That looks good. I'm going to hit save. Horizontal line through y equals 6. My slope is 0. We're good to go. Okay. Write the equation of the horizontal line. Okay, again, so here's another example where we're working with a horizontal line. So because we have a horizontal line, that means you're just going to have y equals, in this case, it's going to be y equals 3. The slope is 0, it's just y equals 3. Find the equation in the line with the given slope and intercept. Again, the slope is 0. So if the slope is 0, we have a horizontal line through y equals 1. Y equals 1. And these have all been quick like that because these last few examples have all been horizontal lines. Okay. Use the given conditions to find the equation in slope-intercept form. Okay, so they gave us the x-intercept and the y-intercept. Let's take some notes on this one. Let me zoom in some. That's too much. Oh, I don't have my little option over there. That would have been nice. That's okay. Let me see if I zoom in again, what happens. I just don't like the way that looks. That looks better. Okay. So, I'm getting these copies in a certain way intentionally, so that way we have the question ID associated with each question. So when we go to pull these up later for reference, we know where in the book it's coming from, right? So this comes from section 1.2. This comes question 25 from the back of that section. So let's hop back over here. Nope, not there. Here. Almost lost it. That's okay. And we're going to drop it here for right now and add a page or two. Let's add a few pages. Okay. All right. So this is the one that we're working on. So now they give us the x-intercept and the y-intercept, right? So let's write those as order pairs. The x-intercept, that's going to be -1, 0. A y-intercept is going to be 0, 9. We want slope-intercept. So we want to finish in the form y equals mx plus b, right? So we want to finish in the form y equals mx plus b. We actually have, they gave us b. So we know that our y-intercept is 9. The slope, we need to find it. So let's use the slope formula. That's going to be y2 minus y1 over x2 minus x1. And again, this is our slope. Okay. And since we have a set of ordered pairs, let's go ahead and label them. x1, y1, x2, y2. Okay. So then if we plug in the corresponding parts, it's going to be 9 minus 0 divided by 0 minus -1. Notice my use of parentheses. So then that boils down to just 9. So we have our slope. We have our y-intercept. So then now we're ready to use the y equals mx plus b. So we can say y equals m, which is 9x, and our b is 9. Okay. And it is a good idea. Whenever possible, you want to check. So what we can confirm that the original points are on this line, right? Sometimes we don't have the luxury of checking, but whenever we do, we want to check. So when x is -1, y should be 0, and I think that one checks out. When x is 0, y is 9, so that checks out. So we got 9x plus 9. Okay, we're going to hop back to Pearson. Let's zoom out a little bit. And I think we got 9x plus 9. 9x plus 9. And it's an equation. So we need to do y equals 9x plus 9. Let's check our answer. Okay. We got a solid 10 minutes. Let's keep going. Find the equation of the line that contains the point and is parallel to the line. Okay, so if our notice the given line is y equals -2. If our line is parallel, that means our line is also a horizontal line. It's going to be parallel to the x-axis. So in our case, that means it's just going to be y equals +2. So it's going to be y equals 2. There it is, y equals 2. Again, you just got to stop me if anything is not clear if I'm going too fast. Write the slope-intercept form of the function whose graph satisfies the given conditions. It passes through this point and is perpendicular to this line. So I think this was the question that one of the students had, and we answered it specifically. If the given line is x equals 12, which is a vertical line, and our line is perpendicular to that one, that means our line is going to be a horizontal line. So because we have a horizontal line, it's just going to be y equals -8, right? So y equals -8. I'm really pleased with this keyboard. I got this keyboard specifically, it's a Bluetooth wireless keyboard. I got it specifically because it has a number pad. And for a while, it was just not working. Or I guess I wasn't used to it. Like I just could not get it to work. It was not working. I finally worked out the kinks and got it working, and it's like a dream. And like you can change the background colors. I feel like I'm doing a promo for it. My friends are like, you need to do commercials. The way you talk like you're doing promos. It's like, yeah, no, I watch way too much TV. And I avoid commercials now. Like I intentionally avoid commercials just because I feel like it's a lot of brainwashing of stuff that I don't want to have in my psyche. But anyway, decide whether the lines given are parallel, perpendicular, or neither. So lines that are parallel means they have the same slope. Lines that are perpendicular means the slopes are negative reciprocals of each other. Or in other words, their product is -1. So when lines are perpendicular, the product of the two slopes is going to equal -1. And if neither of those cases happen, then that means that it's neither parallel nor perpendicular. Okay, so we want to decide if the lines given are parallel or if they're perpendicular. Okay, so basically they're asking us to compare the slopes. That's too much. So I'm gonna go like this. Might have time for one more after this. I hate to cut that off. I'm gonna go like this. Okay. So whenever we're working parallel, perpendicular, and neither, what we're doing is comparing the slopes. Come on. There it is. So parallel, perpendicular, or neither means compare and contrast the slopes. Okay. So we need to find the slope of the lines of these two lines between these points, right? So the first line passes through, we have this -5, 6 and 5, -2, right? So we said we're going to find the slope. So that's going to be y2 minus y1 over x2 minus x1. Again, this is our slope. This is for, I'm just going to say line 1. I'm going to label it like this. And I'm a fan of labeling my coordinates, each component. So then x1, y1, x2, y2. And then now let's just plug them into the slope formula. So the slope for the first line is going to be -2 minus 6 divided by 5 minus -5. Okay. So on top, that's the same as -2 plus -6 is -8. On bottom, double negative becomes positive. So that's a 10, which reduces down to 4 by 5, okay? So then for the second line, we're considering the points 6, comma, -9, and -4, comma, -17, right? So then let's label our points, x1, y1, x2, y2. And now we want to go ahead and calculate the slope for line 2. So that's going to be -17 minus -9 divided by -4, all these negatives, right? Minus 6, okay? So notice my use of parentheses to keep track of those signs. So on top, we got a double negative going on. So we got this -17 plus 9. And yeah, this is fine for that, okay? And then on bottom, the bottom is the same as -4 plus -6 to give us -10. So if we keep going on top, 7 and 1 is what? 8. So that's the -8 divided by -10. Double negative is positive, so that reduces down to a positive 4 by 5, right? So for the first one, we got -4 by 5, and the second we got positive 4 by 5. These are not the same, and these are not negative reciprocals. So just trying to make sure I did it proper. So this is an example that should be neither. This should be neither. It's neither parallel nor perpendicular. Right? So we're gonna say neither. Okay. And with that, I have that we are essentially out of time. Are there any burning questions? Any burning questions? So just to kind of recap, I'm going to make it where with each session, every time, whatever you see me writing, I'm going to make it available for you. Right now, I just haven't set it up all the way, but I'll get it done shortly. I intend to load like a student version of the notes where it's basically like definitions, correlates, things like this. And then it'll have the examples, but it'll only have the questions with no supporting details. My recommendation is you want to attempt those examples without the support and see how far you can make it. And then once you've made it as far as you can, she might be over there sniffing. Once you've made it as far as you can in the student version of the notes, then you want to take a copy of the instructor version. You'll see it's going to be a couple of different folders or whatever. Then you want to fill in the missing details. The instructor versions that I'll load at each session, they're going to have way more details than the student version. Our assignments are due weekly, every week, Sunday night at 11:59. And remember, exam 1 is coming up just before the start of week 4. It'll be available for 7 days. And in order to access exam 1, you have to pass the corresponding quizzes. I made a prerequisite. So it's the quizzes for weeks 1, 2, and 3. You have to pass those in order to access exam 1. Also, when you go to take the exam, it's unlimited attempts with only a 10% late penalty. The system is set to take your highest score, but each time you take the exam, it's going to give you a different exam. It's going to be the same content, like the same material, but it's going to be different questions, right? So what that means is you want to do your best to try to be as comfortable as possible going into the exam. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your weekend, guys, okay? Work hard, but then play hard. Be sure to get your work done, but then try to get out and enjoy the city a little bit. So I'm a fan of the Beltline. I love the Beltline. I like to go there a lot. It's always good vibes there. People just exercising, trying to zen out for the most part. It connects to Piedmont Park and all these restaurants. It's a good time. Just work hard. Be sure to get your stuff done, whatever it is you need to do. Link up with the tutors, work together. But then once you've gotten to a certain point, play hard. You got to get some kind of balance. All right. So with that, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your weekend, guys. Take care. Peace. Okay.
Sir, actually, I had a question.
Go ahead.
So With my Pearson account, I just been able to log in yesterday,
Okay.
and it's not allowing me to. So I'm assuming this is just the Pearson problem, and I can't because I can't log in
What is it? Is it
right
like you
now.
can't get login screen or?
Yeah, I'm in the login screen, and I can't really log in right now.
What kind of error message are you getting?
It's let's see. Oh, actually, I just figured it out. Thank you. Yeah.
So
And then
if you're able to log in to access our material, what you want to do is go to Blackboard.
got you.
So go to Blackboard. Like let me walk you through it. So if we hop over to Blackboard
and go to assignments.
Yeah, folder number 4 assignments.
Gotcha.
It's in there. And then you should be prompted to log in, and then everything is there. Because that's how you access it. I linked it to.
All right, perfect. Yeah, okay, I see it now. Yeah, thank you. Also, I did have another question though. For graphs and equations, where I had a question on the. Hold up, I'm pulling it up right now. It's asking for the collinear points, and I was having trouble, especially like determining whether or not it was collinear.
That question, click on the Ask My Instructor. It's going to email it to me. I'm going to pull it up right now, and we can talk about it.
All right, let's see. So it says, is it under Get More Help or?
Yeah, Get More Help, and then Ask My Instructor.
Ask My Instructor. All right, perfect. And then I'll send it. All right, I just sent it.
All right, so I'm pulling it up. This comes from section 1.1, question number 11. Hang on. Let's see if I go like this. Determine whether the 3 points are collinear. So yeah, this is a good question. I know one of my students, I did make a video on this one already. So it is a good idea to be subscribed to my YouTube with your notifications turned on. So that way, you know, because this I had another student that had the same question, but I don't mind doing it right now. Since we're here in the same space. Yes, no worries. I want to share this here. That's fine. And then can I just insert the last image? That's not the right one. This one. Okay. So this comes from, we said section, I think it was section 1.1, question number 11. So let's see. Again, this comes from 1.1. I think it's question 11. Let me just check real quick. Done. You can delete that. Here. Yeah, okay. And then let's see. So collinear, right? So this question is really a question on the distance formula. There's at least 2 different ways to go about it. You can find the equation on the line through 2 points and then verify whether the 3rd point is or is not on that line. Or you would have to do the distance formula 3 times with all the combinations. And then if they're collinear, I think it's like this triangle inequality where if you say the sum of the 2 shorter legs should equal the longer leg. If they're equal, then they're collinear. If they're not equal, then it's not collinear. So let's take a moment right now and go ahead and do the distance formula. We'll do both of them just because we're here. So the distance formula between 2 points. So if you have your formula, this will go in there. It's going to be the square root
of x2 minus x1 squared plus y2 minus y1 squared.
Okay. And square root of all of that, right?
Right.
So I'm a fan of labeling my points, x1, y1, x2, y2. And for this one, I'm going to just go x3, y3. Okay. So then I'll just say the first distance. I'll call it D1.
Okay.
X2, so we're going to say -3 minus 0 squared plus -18 minus a -4 squared. So the challenge there is keeping track of the signs.
Got you.
Those negative, right? So then -3 minus 0 is -3. -3 squared is a +9. Okay. Let me see. In the second one, we got a double negative, so that becomes a plus. So -18 plus 4 is -14. So then you got to say -14 squared. Hey Siri, what's -14 times -14?
-14 is 196.
196, right? So that's going to be plus 196. So then 205, that's the square root of 205. 40, 41. Okay, so we're going to leave it like that. Square root of 205. That's the first one, right? With the first 2 points. So now I'm going to find the distance between the first and the last. So I'm just going to call this D2. So it's the same thing, just using the first and last ones. So then it's 2 minus 0 squared plus 6 minus a -4 squared, square root of all of that. Is this okay so far?
Yes. So the first one you ended up using X1 and X2, correct? For distance one.
Oh, for distance 1, yeah, right? So I use these 2 points.
Gotcha.
And
just making sure.
Yeah, and then distance 2, I use these 2 points.
Okay, got it.
Okay, so that's what, a 4. Double negative is positive, so it's 100. Okay, so we got the second distance. So we did the first and the second, that was distance 1. We did the first and the third, that was distance 2. So now we're going to do, for distance 3 is the second and third, the last 2. So then it's going to be 2 minus -3 squared plus 6 minus negative squared. Okay. So, again, this is the technique where we're doing a distance formula 3 times. The 5 squared is 25. What is that? 24? 625. Hey Siri, what's 24? 24.
24 times 24 is 570.
I think she said 576. Square root. Okay. So then 601.
About, yeah.
Okay. So then now, if they are collinear, if we say this result plus this result, it should equal this result. Hey Siri, what's the square root of 205? I stammered.
The square root of 2,205 is approximately 46.954.
Hey Siri, what's the square root of 205?
Square root of 205 is approximately 14.3178.
14.3178. It's an approximation. Plus, hey Siri, what's the square root of 104?
The square root of 104 is approximately 10.198.
198. The question is, does that equal? Hey Siri, what's the square root of 601?
The square root of 601 is approximately 24.5153.
I think she said 5153. Right. As you can see, if you say this plus this, it does indeed equal this. I think we're good there, right? So that's a yes.
So that would
be a
mean it
yes.
was collinear.
They are collinear, right?
Gotcha.
Let's do the alternate method really quickly by finding the equation of the line through 2 points. So I'm going to use the first and third because those just look more simple. I'll do this in blue. Let's do orange, right? So we're going to do the slope, which is y2 minus y1 over x2 minus x1. Okay. So then I'm going to use the first and third point. So I'm going to say 6 minus -4 over.
Would you say this was more efficient?
I feel like it is.
Okay.
2 minus 0. That's why I'm showing. I just want you to be aware of it. So the slope between the points is what? 10 divided by 2, so that's 5. Okay. So we have the slope. We need the y-intercept. Oh, we have the y-intercept as -4, right? We got lucky because they gave it to us right here. So that means our b is -4. So let's see, we got an m of 5 and a b of -4. So then we can jump straight to y equals 5x minus 4. Then what we want to do, first we want to verify that this works for our 2 points, and then we want to see if it works. So for instance, when x is 0,
all right,
notice y is -4, so that checks out. When x is 2, 10 minus 4 is 6, so that one checks out. So then now we want to see, we already know it should be yes, but again, so now when x is -3, that's going to be a -15. Uh-oh, wait a minute. Maybe it's not close enough.
Okay.
You know what I'm saying?
Wait, hold up.
So
okay,
the problem here was that it was close, but it wasn't exact.
Okay, so that means it's not collinear?
Yeah, it should be not collinear.
Okay, got you. So is this a good checking method?
Yeah, I feel like that's why I went on and did the orange, because you want to be exact, and we were rounding with these results, right?
Sure. Okay.
So that's why they got off.
Got you.
Right. So, but this was exact. So then this showed us that last one. It was really close, but it wasn't on the line. So it should.
Got it. So with the new method you just spoke about, should I be using that as my first? Like, should I just go about doing it that way so I don't have to round?
Yeah, I think so.
Okay.
I mean, because they really do want you to do the distance formula 3 times, but that's a bit extra. If you're doing collinear, I prefer the way we did it in orange.
Okay, gotcha.
Yeah. I personally prefer it. I feel like it's less likely.
I feel like there are less variables, yeah, because you're gonna have to round.
Less chances to make mistakes.
So, like with rounding with Pearson, how should I round to the nearest 100th or 1,000?
They usually tell you if they want you to round, they'll say round to the nearest whatever.
Gotcha.
Or they'll be exact using radicals or fractions as needed.
Okay, cool. All right, I do appreciate that because, I think I have a much better understanding about how to do this. Because with the second method, just so I can explain it, so I know what I'm talking about, and you can tell me if I got it wrong. But we basically use y2 minus y1 over x2 minus x1. And then with doing that, after we've labeled all 3 points, then we will, if we get lucky enough, one of our points may be the y-intercept. But if not, we would have. So how do I figure out the y-intercept if not given that coordinate?
Okay, that's a good question, right? So if the b was not given, if the y-intercept is not given, then you have to go to the point slope. Once you have your slope and a point, then I think that's essentially what today was about, was the point slope.
Okay.
So you use the y minus y1 equals m times x minus x1.
Okay.
Let me write that one.
Yeah, I have to see that. Was that just the slope formula?
No, there are 3 formulas.
Because I did write a formula down. Was that just y2 minus y1 over x2 minus x1, or delta y over delta x?
So it's three different formulas, and two of them are very similar. Let me do this. And what's your favorite color?
I don't know, black.
Black. I'm gonna go navy blue. I just need to. Okay, so when we're working with lines, I don't know if you remember me sharing this, but
Mhm.
there are three formulas that you want to have. The slope formula is the first one, right? We just
Gotcha.
saw a demo. That one is y2 minus y1 over x2 minus x1. That's the
Gotcha.
slope formula.
And wait,
And then the
can I
next,
just sorry, didn't mean to cut you off, but can I just do delta y over delta x?
yeah, as long as you know it means
The
this,
change.
then that's
Okay, yeah,
yeah.
okay, perfect. Okay.
Changing y over changing x. As long as you know it means this, that's fine.
Perfect.
And then the next, whenever we're working with lines, the next one is the point slope. Point slope. So the point slope is where if you suppose you were not given the y-intercept and you wanted to find the y-intercept,
Mhm.
that's where the point slope will come in. And you use this whenever you're given a point and a slope, right? So in that example, orange, we knew the slope, but we didn't have our y-intercept, but we had a point, right? So that's where
Right.
we use this one. And this one is y minus y1 equals m times x minus x1. So if you plug in that slope we found and one of the points here, then you can solve for y and you can find your b. And then the last formula whenever we're working with lines is the slope intercept. Kind of run out of space. Slope intercept. This is where you finish with the y equals mx plus b. Just give me a moment. I want to just resize the stuff. Right. So whenever we're working with lines, we typically like flow between. You want to have these three formulas ready to go.
Gotcha.
And oftentimes the goal is to finish with the slope intercept. So you that's where you ask the question: what if we're not given the b, then we should rely on this one.
Okay.
There is another technique where you don't really need this one, but for our purposes, if you're not given b, then just use the point slope.
So why am I? So I had to ask, but could I see you use point slope? And
Have you? Oh, wait, you want to see me use it?
yes.
Okay. So in this example, suppose we did not use the zero negative
right,
and we use these other two, right?
Gotcha.
So, well, we got that it's not collinear.
Mhm.
You see, we got the slope. Let me think. Okay, so instead of using this point here, I'm going to use the slope that we found. This guy here, this 5, and I'm going to use this 2, 6. So we have a slope and we have a point. Right. So once you have a slope and a point, you just plug that into the formula. All right. So point slope. Let me start over. So if I have my y minus y1 equals m times x minus x1, and I think we just said that our slope was 5, and we're using the point, I think it was 2, 6. 2, 6. Instead of using the 0, 4, we're using the point 2, 6. This serves as our x1 and our y1, and this is our m. So then, if we plug it in, we're going to have y minus 6 equals 5 times x minus 2. Is that okay?
Yes. Okay, so okay.
Y1,
right.
m, x1. Okay, so then from here, we want to solve for y. So it's basically 2 steps. I'm going to distribute the 5.
Yeah. Okay.
And
I think I just wanted to see like how you went about doing finding their your values. So I understand. So I think the only thing I'm having problems with is 5, and you got that from, you got
The
your
slope.
M from your slope. Got you.
Yeah.
Got you. Thank you. Got it.
Right.
Okay.
Give me a second. 5x, what is that? -4? Is that the same thing as what we had before?
Mm, yeah, 5x minus 10, that's 6.
Yeah. You see it right here. 5x minus
Right.
4.
Right.
And 5x minus 4. Right.
Mm-hmm.
So the moral of the story, if you're trying to find the y equals mx plus b and you're not given the b, that's when you use the point slope. So if you're not given b, we use point slope. And then we can use that to find. That was actually a really good question.
All right. Ooh, okay. Yes. Yes.
And it's like at first glance, at the introduction, it is a bit much, but as the anxiety comes down, the more repetitions you do. So the more you kind of, it's like anything. Like, I don't know if you've ever like set up a computer or like the first time you do anything is jarring as a learning curve. But then as you get the repetition in, as you get the reps in, then it becomes second nature. Right. And so this is just a game of how many reps can you get in given the allotted amount of time. You know what I mean?
Can I ask you another? Yeah, I do.
Yeah.
So I have another question about Alex and like how that's supposed to be. And so are we supposed to be doing Alex Lab while also doing Pearson?
Yes. Yes, you are. So the Alex, so Pearson is for me, for our stuff, like for our. But Alex is the lab component. So what you have to do there is when you go into Blackboard, can you still see my screen?
Yes, I can.
I think I'm gonna just audibly walk you through it. When you go to Blackboard, on the left-hand panel is gonna say Online Alex Lab. You want to click on that left-hand panel and then contact Dr. Lamar. She's the one that's like running the lab portion, the Alex Lab. And so basically whatever she tells me to do, that's what you do. She's gonna give me a grade, and I'm gonna use that to scale it to count for your lab portion of the course.
Gotcha.
Pearson is how I do my stuff, but then Alex is how she does hers. And these are different systems. Where Pearson is basically trying to get us up to speed on the new material. What Alex does, as you kind of work through the material, it identifies content that you might be deficient in, and so it'll give you practice on areas that you're deficient in. She'll give you the overview of that.
So is that like a separate class or?
Pardon? It's yeah, but it's done in an unconventional like time. So you have to like just contact her. She has all the details for that. That's something that's separate, and whatever she needs for each of you guys for that, that's what I'm going to use for your lab grade.
Okay. Thank you.
Yeah, these are good. And we're still live streaming, so I'm glad that you're asking these questions. So hopefully others can like see this interaction or whatever.
Right.
Yeah. All right.
Oh.
Do you know how to find the Alex information, or you need me to show you?
Yeah, she sent an email. So yeah, I have the syllabus for that portion of the class now.
Okay.
Right.
All right.
Thank you. I do appreciate you, Professor Stan.
Yep. It's my pleasure. Any other questions going once and going twice?
I think I'm good right now, sir.
Okay. All right. So with that, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your weekend. See you Monday, same time, same place.
Yes, sir. All right. It's been a pleasure.
Bye. Peace. Henry, is this a... Let me make sure he's not in this class. Oh, I got him. Okay, Henry. Mr. Henry, are you there? You there? Going once, going twice? I'm assuming that you're Shiloh Henry.
Hi, Professor Phifer. I was wondering for the meeting for like on in the lab. That was supposed to be online.
Yeah, so I just got off with, I'm not even really sure. But one of the students kind of hung back and we kind of went back and forth on a few different questions. And he asked about the lab, right? So Pearson is how I'm managing, for our portion, right?
Right.
And the lab, which is Alex, that's run by Dr. Lamar.
Okay.
And so to access that is basically on Blackboard. When you log into our Blackboard page, on the left-hand panel, it's going to say Online Alex Lab.
Okay.
You just open that link, contact Dr. Lamar, and she's running that portion. So she has all the details of what you need to do there.
Okay. All right. Thank you, Mr. Bishop. Phifer.
Yep, my pleasure. Any questions?
No questions. Thank you.
Okay. All right. Enjoy your weekend. I'll see you Monday, same time, same place. And from one beautiful mind to another. Peace.